Good morning, everyone, and welcome. I'm Ms. S. Selvanyaki, an assistant professor in the Department of Computer Science at Sri GVG Visalakshi College for Women. Today, I'm excited to present to you on the topic of Web Application Messaging Protocol. Over the course of this presentation, we'll explore the key concepts, how it works, and its importance in modern web development. Let's get started and dive into this fascinating subject. Welcome to our second slide. Today, I want to introduce you to WAMP, which stands for Web Application Messaging Protocol. Essentially, WAMP is a communication protocol that allows different parts of an application or system to talk to each other in real time. It achieves this through two main messaging patterns: remote procedure calls, or RPC, and publish-subscribe, often called pub-sub. RPC is like making a direct request for a specific action, while pub-sub enables an event-driven approach where messages are broadcasted to multiple subscribers. These features are incredibly important, especially in the context of the Internet of Things, or IoT. In IoT environments, devices need to exchange data seamlessly and work together smoothly. WAMP facilitates this by making device interoperability straightforward, which in turn improves the responsiveness and scalability of IoT systems. Connecting this to our overall theme, understanding how protocols like WAMP enable real-time, efficient communication is essential for building smarter, more connected systems. Let's take a closer look at what WAMP actually is. WAMP stands for Web Application Messaging Protocol, and it's designed to facilitate communication in web applications. Essentially, it's a protocol that provides two key messaging patterns: rooted RPC, which means remote procedure calls, and pub-sub, or publish-subscribe messaging. These patterns are fundamental for building interactive, real-time applications. The core components of WAMP include clients, routers, and realms. Clients are simply the applications or devices that want to communicate. Routers act as the middlemen, directing messages between clients. And realms are like communication spaces where sessions are managed. Think of them as separate channels for different groups of devices or applications. One of the most important features of WAMP is its support for asynchronous messaging. This means messages can be sent and received without waiting for an immediate response, which is crucial for real-time environments. This makes WAMP particularly well-suited for IoT applications, where continuous data flow between devices and servers is essential. In these dynamic environments, having a protocol that can handle real-time, asynchronous communication is a game-changer, enabling more responsive and efficient systems. Let's take a closer look at the architecture and protocols behind WAMP. WAMP primarily operates over WebSocket or raw socket transports. This choice ensures that the communication between devices is not only efficient, but also bidirectional, meaning data can flow freely in both directions without unnecessary delay. At the core of its architecture is a router, which plays a crucial role in message distribution. Think of the router as the traffic controller, directing messages to the right destinations. The clients, on the other hand, are versatile. They can act as callers or callies when initiating requests, or as publishers or subscribers when sharing or receiving data. This layered design is intentionally built to support scalability and flexibility. That's especially important in IoT networks, where we often have numerous devices with varying connectivity needs. Whether a device is constantly online or intermittently connected, this architecture helps ensure reliable communication across the network. Overall, these design choices make WAMP a robust protocol for managing complex, dynamic IoT environments, enabling seamless interaction among a multitude of devices. Let's take a closer look at the security features that WAMP offers. One of the key aspects is that it provides built-in security mechanisms, such as authentication and authorization. These are essential for protecting IoT communications, making sure that only authorized devices and users can access the system. WAMP supports various methods to achieve this, including challenge response authentication, which adds an extra layer of verification, and transport layer security, or TLS, which encrypts data during transmission. This encryption is crucial for maintaining data integrity and confidentiality, especially when devices are operating in environments that might be less secure. Ultimately, these security features are vital for safeguarding sensitive information and building trust within IoT ecosystems, ensuring that devices can communicate safely and reliably. This aligns perfectly with our overall goal of creating secure and trustworthy IoT solutions. Let's talk about the benefits of real-time communication with WAMP. As many of you know, in IoT applications, immediate responsiveness can be crucial. WAMP makes this possible by enabling real-time data exchange, which is essential for devices that need to react quickly. One of the key strengths of WAMP is its dual messaging patterns. First, there's RPC, or remote procedure calls, which allow for direct commands to be sent to devices or systems. This is great for precise control when you need to invoke specific actions. Then there's the publish-subscribe model, which is perfect for broadcasting events to multiple devices or systems simultaneously. This pattern supports efficient, scalable communication. Think of it like shouting out an update that everyone interested can hear instantly. Together, these patterns enable devices to interact seamlessly, creating dynamic and adaptive system behavior. This is especially valuable in smart environments, where automation, monitoring, and control need to happen quickly and reliably. So overall, WAMP's real-time capabilities are a powerful tool to enhance responsiveness and efficiency in IoT networks, aligning perfectly with our goal of creating smarter, more connected environments. Now, let's look at some of the key use cases for WAMP in IoT networks. As you can see, WAMP is actually applied in a variety of contexts, including smart homes, industrial automation, and even connected vehicles. What makes it so versatile is its ability to facilitate seamless communication between different components like sensors, actuators, and cloud services. This smooth data exchange is crucial for making informed, data-driven decisions in real time. Another important point is that WAMP's scalability and reliability are what make it particularly well-suited for managing large and diverse IoT deployments. Whether you're dealing with a few devices or thousands across different environments, WAMP can handle that complexity efficiently. Overall, these use cases highlight how WAMP supports the broader goal of creating interconnected, intelligent systems that are responsive and reliable, which ties back to our overall theme of building smarter, more efficient IoT networks. Now, let's talk about how WAMP integrates seamlessly with common IoT protocols like MQTT and CoAP. This compatibility really boosts interoperability, meaning different devices and systems can communicate more effectively. By using gateways or middleware, WAMP acts as a bridge, connecting traditional IoT devices with web-based applications. This is a game changer because it allows organizations to leverage their existing infrastructure while adding powerful new features. For example, remote management becomes much easier, and real-time analytics can be implemented to gain immediate insights. Overall, this integration reinforces the idea that WAMP is a flexible and robust solution for modern IoT ecosystems. So, to wrap things up, WAMP really offers a robust and scalable framework for real-time communication within IoT systems. What this means is that, as your network of connected devices grows, WAMP can handle that expansion smoothly without sacrificing performance. Its flexible architecture allows it to adapt to different types of applications and environments, which is crucial in the diverse world of IoT. Security is also a key aspect. It's built into the framework, helping to protect data and ensure safe interactions between devices. This is especially important because IoT devices often handle sensitive information or control critical systems. Another important point is that WAMP facilitates efficient data exchange. It streamlines communication between devices and systems, making integration with other protocols much easier. This interoperability is essential for fostering innovation and enhancing overall performance across various IoT environments. In essence, WAMP is a versatile and secure tool that supports the evolving needs of IoT, enabling smarter, more connected, and more reliable systems. Thank you so much for your time and attention today. I really appreciate the opportunity to share these insights with you. If you have any questions or want to discuss any of the points further, please feel free to reach out. Remember, the ideas we've explored are all about driving innovation and creating value in our work. Once again, thank you for being such an engaged audience. I look forward to connecting with you all soon.